today we're going to go over a question that we get. How can I validate the health of a wire, right? One wire is 0.5 ohms, another wire is 0.3 ohms or 0.2 ohms. Well, in the aircraft maintenance manual, we have a procedure called relative percent, where we compare a like wire to another like wire, to its sister wire. So if I have 22 gauge 50 foot run of wire, I can compare it to another 50 foot run in that same run going through those same connectors. I can validate the health of the crimp, the splice, broken wiring strands, bonding, corrosion. I can do all that very simply. And in this case, I'm going to use the WA2025 Advanced Multimeter and use the low ohm position. Low ohm uses up to 20 volts, 10 milliamps, gets us over the EMI noise floor, so I have a nice stable measurement. On wing, if I am just in continuity mode in measuring, that inductive EMI makes our measurement fluctuate and I cannot get that precise of a measurement. So this is going to use basically bonding meter type voltage and current and be able to validate the health of this wire. I'm going to compare two twisted pairs of wires. The first pair, let's just connect to it. I'm just going to set a reference on this first pair. I'm going to connect up and you're going to wait 10 to 20 seconds. Make sure your leads, the first time you use them, they're seated and you get the film off of them. And then just select relative and then hit it again, relative percent. What I set was a reference of 1.017 ohms. There's my deviation from that 1 ohm, and it's going to continue to go negative as I induce cleaning current. So that's okay. See how it's negative 1.37? That's fine. I'm well over 20 seconds now. Now I'm going to move to my next pin, its sister wire. And when I connect, I'm just going to count down to 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I can hit hold. And you see, I want to be below 1%. So I was positive 1%. Now I'm at negative 1.08%, again with the cleaning current. I have a 0.009, so I'm in micro ohm deviation from my reference. This is healthy. This is a very healthy wire. If I deviated positive 7%, 8%, 100%, 200%, that would be bad. So this is a good wire. Now let's compare to the other set. I'm troubleshooting. I got to figure out which wires are good, which wires are bad. I'm going to cycle this off and on again. Low ohm. I turn on my backlight and let's compare it to another pair. All right. So I'm in my next pair. Again, I'm counting down to about 10 seconds. Make sure I'm seated in here, nice and stable. And then I want to select relative again, relative and relative percent. And now I'm just going to move to my next wire. You see I have a baseline of 0.984 milliohms, 984 milliohms. And again, 10 seconds, 10 to 20 seconds. You're just going to count. And then I can hit hold. And you see I'm 62%. 62% tells me, in positive 62%, tells me this wire has more resistance. It has 0.6, a little over half an ohm deviation in resistance from the original reference. So on this the first twisted pair was good. The second twisted pair, I either have broken wiring strands or I have a poor pin socket retention, poor bond if it's going to a ground. So I can focus on this last wire that I tested. So 3 out of 4 wires, I had, it seemed to me, a good measurement. And on the fourth one, I have a 62% deviation. In the book, in the AMM, we're looking for a positive 1% deviation, an increase in resistance, and that would drive us to use a time domain reflectometer or another tool in order to help us find the exact distance to fault. And that will be in another video. That's it.